All right, so I was asked to use the projector that doesn't work. Here we go. I was asked to talk about TDD and unit testing, and I apologize for sitting down, but most of this is going to be a live demo because that's kind of what I do. Speaking of which, before we get to that, I'm Gary Bernhardt. I look like that on Twitter and troll a lot, so if you see my face, you can now hit me in person for whatever I said in the internet. And I'm going to show you, first of all, a demo of the London style of TDD, which is a particular sub-school of TDD that I happen to be very familiar with. Can you guys read that in the back? Like if I type text, is that readable? Can anyone not read that? Okay. I'm going to do something out of the series of screencasts that I'm currently publishing on Destroy All Software. So I'm going to show you a class called RockScore, and this is part of an application called SucksRocks. What SucksRocks does is you ask it about something like Microsoft, and it goes off to a search engine and searches for sentences like Microsoft rocks or Microsoft sucks, and counts how many results those give you. So for example, Microsoft rocks might return 1,500 results, Microsoft sucks might return 500 results. From that, it computes a ratio of the positive to the total mentions of this thing, so 1,500 over 2,000 in this case, which is 75% positive, which turns into a score of 7.5. So that is all that SucksRocks does. Now I'm going to start with this empty file and just start test driving what the score computation might look like. I'm going to describe a class called RockScore and hopefully capitalize it correctly. And what does RockScore do? Well, it computes scores, but that's not really, that doesn't tell me anything. A more concrete thing to say might be it returns low scores for unpopular terms. What does it mean to return a low score for an unpopular term? Well, it might mean that the rock score for some term, like Microsoft, might equal 0.0. So I write an assertion of that form. But what do I have to do in order for that to be true? Well, maybe RockScore is going to use some search engine class and ask it to do a search for it and say, count the results for the search Microsoft rocks. This is what I want RockScore to do. Of course, RockScore does not exist yet. Search engine does not exist yet. I'm just programming by wishful thinking. To force this to happen, I'm going to stub out the method count results with the string Microsoft rocks as an argument and tell it to return, let's say, 0 results for Microsoft rocks, and then the same thing for Microsoft sucks, returning, say, 10 results. And by the formula I showed you earlier, that should result in a score of 0.0. Now, I've just done a bunch of design of my system. There is no system. There's only a test. There is no other source file in this directory. This is sort of the essence of TDD, is that you are doing design by writing a test for something that does not yet exist. If I run this, of course it will fail. Uninitialize constant RockScore because the RockScore class does not exist. So I'll cause it to exist. It doesn't matter what's in it. I'm just satisfying the failure that I saw. Run again. Search engine doesn't exist. I'll cause that to exist. Run it again. The for-term method doesn't exist. I'll cause that method to exist. I don't care what it does. I just care that it changes the message. Run it again, and I expect 0.0, but I get nil because methods return nil by default. Well, I can make this test pass by just saying 0.0. And this is sort of the second essence of TDD, is that I just did the simplest possible thing to change the message or make it pass. And now I have a passing test. Now, because this code is stupid, this is not even code. There's nothing being executed here. This is a constant, effectively. So the stupidity of this code is telling me that I must write another test. Maybe something like it returns high scores for popular terms, which is the opposite of the one I just wrote. That test is almost identical. In fact, I can copy and paste this and just have a lot of positive results, few negative results, and I expect it to compute that into a higher score, like 10.0. If I run this, of course, it fails because it expects 10, but it got 0. Now, the actual formula I showed you earlier, which is what I now need, was the positive over the total times 10. That's the score. The total is how many positive I have plus how many negative. The positive is a result of searching for the term rocks, and then the negative is the same thing, searching for the term subs. This is the code that these tests were trying to make exist, even when I wrote this first test and was just doing design by writing the test. If I now run this, the test passes. Now you can tell I've done this before because everything's working the first time. In reality, it would be very messy and gross. This is what test-driven development looks like. And the fact that there are stubs here is happening because it's London-style TDD. So what the hell did I just do? First of all, it was outside-in test-driven development. I designed my class under test by writing tests. That's always how TDD works. But I also designed the search engine by writing a test for RockScore. The RockScore class stubbed out or mocked search engine, which defines the interface for the next class I will drive, lower down in the stack, which is search engine. Second of all, I was doing outside-in TDD, which is a three-step process. Write a failing test, it must fail. Write minimal code to cause that test to pass, and then refactor. I don't have time to do a refactoring demonstration in a 10-minute talk, but this is the step that gets overlooked the most. If you are not doing these three steps, you are not doing TDD. Writing tests is not TDD. Writing tests first is not even TDD. It must fail, and you must write minimal code to make it pass. And you must refactor. See? Always forget refactor. The third thing that happened, in addition to it being outside in and it being TDD, is that it was unit-tested TDD. A unit test, by my definition, is a test that tests one object behavior, a specific behavior of a specific object. So this means you are not integrating a giant system and testing that. You are testing one small piece. And the second thing is that other objects can't break the test. So in my test for RockScore, if the search engine class did exist and were broken, this test would not fail. And this is not a problem. This is actually a desirable attribute of a unit test. The idea is that if I run my full suite and one class is broken, only the tests for that class fail. That tells me exactly what's wrong and tells me how to fix it, hopefully. So that's the definition of unit. If your tests don't have these two properties, you are not writing unit tests. That's not a value judgment. It's okay to not write unit tests, but you shouldn't call them unit tests. And finally, the difference between an integration test and a unit test is often one of speed. So if you run 243 tests in 400 milliseconds, those are probably unit tests. If you run those same tests in 40 seconds, those are not unit tests. A unit test is necessarily fast. I'm not saying that I personally think that unit tests must be fast. I'm saying that by the definition of unit test, it has to be fast, because it has to be working only a small piece of the system. Now, I'm not a fan of long talks, so that is actually all I have to say about TDD and unit tests. As is the nature of the screencasting profession, I tend to be very dense. But I wanted to give you a slightly inflammatory, very high-level definition of what TDD and unit tests really mean, because I think they get used a lot incorrectly. This is what people in the software craftsmanship community mean by these terms, and we use them a lot, and they are sort of our core technical practices. So thank you guys very much for listening to me for 8 or 10 minutes or whatever that was.